and this is the valve guide. Comparing the two valves, they are same diameter, is right, and the height as well is that one. So taking into account, we have to work a little bit on the seat of the valve. We should measure the eye of the new position of the intake valve. So this is the axial guide, so we need this to be our direction. So we have to bust the valve to avoid it to follow. Stopped in a position which allows to measure the exceedance of the valve tip from this plane. This tool as a reference when the valve is completely closed. We have to adapt focus to catch a good image of the tip. Washers we have to put in series in the axis which is aligned by this one, because we have to ensure there is a clearance is 32.2. I mean this length, which is the actual one. Then two washers are 1.0 millimeters, these washers, and the spring is 11.75 in the worst case. So if we leave a clearance of 0.35 millimeters, we have at the end 45.3, which is the measure of the seat. Given a linear expansion coefficient of 2.4 times 10 to the minus 5 power, and a length of the aluminium of around 50 millimeters, and a variation of temperature of 100 degrees, the deformation, which is the length times the coefficient times the delta t, is around 0.1 millimeters, which means that if we have a clearance of 0.35 while the engine is running, the clearance will be 0.45. It's better to get a little bit of constraint at the beginning than a clearance while the engine is running. So we insert a second washer, and at the beginning there is an interference of 0.15 millimeters. We are in the intake side and we have to set the seal of the valve.